Hi Twitch, hi YouTube. I guess whenever YouTube starts up. There we go. Hi YouTube, hi Twitch. Hello, how's everyone doing? Why am I so tall? Why is my table so low? Perfect. I hope everyone's having a great day. Let's see. I continued programming since I think last week. Did I stream last week? I think I streamed last week, the technical stream last week with sensors. I've continued a little bit, so I will show the progress on the program first, then I'll explain what we're gonna do today. I mean, it's in the it's in the title. I asked through YouTube actually, right? I made a post and asked, hey, what does my program actually need? And there was like analog sensor, analog sensor, analog sensor, so I gotta make analog sensor stuff. It's that simple. Where is it there? So what do we have? Comments. Hi, thanks for... You're welcome, Sergio. Pressure tank, that's analog, No, not this. Level sensor, encoder, proximity inductive sensor I've got. Laser sensor for distance measurement, that's the one I want to tackle. That is the one. Hey Alexander, hey Egan. Evgen? Difficult to say. Hi, how's everyone doing? Yes, sensors, exactly, we're gonna do sensor. We can, pretty soon, I will connect everything to TIA Portal. Right, so pretty soon. Hi Patrick. How do I remove know-how protection? I don't know how to remove know-how protection. That's why you do it. That's probably a hack, but I don't know how. I haven't done it though. Yeah. So what I did since last time is I added a couple of different sensor types. As you can see here, those sensors. Let's just run the thing. Hey Inka, hi. I could theoretically make it VR, Patrick. It's not too difficult to make it VR, but that's an optional thing. I might leave it for later on. So I've got these sensors now. For example, this one here, just an inductive sensor. And you see the green LED, it turns on and off. I've got like, this one is also digital sensor, a Boolean sensor, just on off. It detects something in the range. And for this one, I can actually, and it's gonna be in the end product that not just the programmer me can change, but everyone. For this one, you can change the distance. Right. So for this one, you can actually adapt like which range is it going to. Now it's going to measure the ground, for example. Hard to see. I know it's very small, but yeah. And then I've got like a Ford-like barrier, so pretty much standard basic sensors. So I think this, I'll push it into the device. Yeah, there we go. And it just detects if there's something in between. We'd love to start with education purpose with VR. Yeah. It's not too hard to change it to VR, so I will try to make it possible to make VFD block motor control. Of course, Ivan, I should be, but I don't know how. I'm not really a motor expert. What is the name of this software? Doesn't have a name yet, Mustafa. I will make a poll at some time, like yeah, I'll ask at some point, and then we are going to give this software name. But this is not all I did. What I've been working on as well, and this is going to take a minute, because now I'm going to teach you something. I'm going to show you something. So what I've been starting to work on is also some actuators. So I've got a pneumatic cylinder here. So this pneumatic cylinder can extend and retract, right? But I've also started to do a lot more components on this. A cylinder doesn't just extend, it needs pressure, right? It's got two ports up here. It's got an outlet and an inlet. And we need to connect pressured air, right? So I've got different DCVs, like a spring. Let's take the spring return. Let's not take the spring. It doesn't matter, I can take both. Let's take the spring return actually. I've got the spring return DCV that I can connect to different voltages and that stuff, so it's really voltage sensitive. But where does the pressured air come from? Of course, the DCV needs to be connected to a pressure source, and I've got like a... this one's the correct size actually. And I've got this as a pressure source right now, which is not a pressure source, but it kind of is. Usually you have a compressor in before. Yeah, pneumatic cylinders, valid, exactly. Am I interested for cooperation or garden the education purpose in Scotland? I just kind of roll. I just do my thing. I get a lot of emails like, do you want to work with us and do that stuff? And I'm always like, nah, no, I just do my thing. It's still just a hobby. How will I simulate an input word signal? That's probably one of the upcoming streams, Alexander. It's not too difficult. It's actually pretty simple. Where can I get the mechatronics? You can't. No one can get it yet. I am the only person that has this. So what needs to be done, of course, this needs to be connected to a compressor. I don't have a compressor yet, so I'm just gonna put... It's pretty hard to see probably, but there. Oh, I don't have it on. I'll say this has 5 bar at the input side, right? Which is my shutoff valve. It has 5 bar. Now I have to connect this to my DCV. That's how it is done in reality. So my DCV has a left input, and I will take the shutoff valve output, put it as the input. There we go. Then, of course, my cylinder has an input as well, ports, and I will connect the output port of my DCV to the input of my cylinder. That's how it works. Max start. I will make tutorials as soon as it's done. I'm still working on it. So that's the pressure side. So if I start it up, nothing's gonna happen. I probably forgot something anyway. So now I could turn the shutoff valve on and off. I can simulate it, yeah, of course. And this is gonna be in the final product as well. I can simulate everything. So shutoff valve I can turn on and off. And it's got, like, if it's off right now, this one will not have any input pressure, of course. If it's on, this one has input pressure on one port, which is this, right? But this is a DCV which has an electrical input that I can control using a PLC, and it's got a spring on the other side. So turning on an PLC output will activate the DCV, and that's exactly, I'm overwriting it right now, but I could do it with the PLC, of course. I'm overwriting it, signal here, and it should be like 24 volts. Like, let's make 24 volts. So the signal on this is now 24 volts. It looks beautiful, thank you. It's all made by me except for this thing here. I'm doing all the models myself. So this one has 24 volts. Now let's see. That means it's actuated. I've got like signals there. It says it's actuated. But this one is not extended. Why is it not extending? It should actually. Oh, no. Huh? This one is extended. The left input is 5 bar. The output is 5 bar. Can I share the models? I can. Yeah. At some point, I'll publish almost everything. The single... This one has at the X10 port 5 bar. Why is it not extending? Wait, did I write more than 5 bar? It might be that I need more than 5 bar. Let's make it 8. Yeah, okay. It needs 8 bar. In theory, valid, right now I cannot connect the cylinder directly to the PLC. The cylinder is connected through a DCV. In the final version, I will most likely also make it available for the PLC, just using signals, but that's not correct. So now if I turn on and off my PLC output, like this, 0 and 24 volts, let's just do this. I can extend and retract the cylinder. And that's exactly what the PLC does. I need valve terminal. Yeah, I mean, there's so many components that I've already added. It's freaking big already. I'm not really planning on like resistors, capacitors, inductors, and that kind of stuff, because it's more about the automation part. It's not so much about the electrical. Then that would be really complex at some point. But I can do this, and this I can, not just in theory, but in practice, do using a PLC. Yeah. But I can't hook it up right now to the PLC because I would have to. I mean, I could. Okay, let's let's take it one step further. Okay. And yeah, I'm just fooling around with what I have done. This is 8 bar. Let's add the PLC. I mean, I already have one here, but I'll just take this, I think. There we go. There is the bad boy. Right now it's just fully simulated. Oh, I need to put too many things on the PLC to make it run. I need to turn on the power on this and that stuff. I won't. And this PLC will be connected also to TIA Portal and a physical PLC. Easy. Can I add in a program resistor capacitor? I don't know what exactly for in here. I mean, I'll try to add as much as I can. Okay, so this is what I've done. So I have now an actuator that I can actually control using different components, which is a lot. It's actually a lot that has happened. But for now, I don't want those. Let's get rid of them, because we want to work on the thing that I named in the title. And that is not this, but this, an analog distance sensor, which is quite some work. I also, for educational, yes, but there's so much more in electrical engineering as well. There's so much. The valve is digital. Right now the valve is digital. I controlled the voltage. Walid, you're right. Right now I controlled the voltage. I made it 23 and 26. So I usually it would just be on off. What am I explaining? Analog scaling? No, Ali. I just explained what I have done here in my program. I won't show it again. You can just watch the replay. So what I want to do today is the following. I will have like something that I want to detect, right? And I want to make a sensor today. So that's going to be one task, to make a sensor. Task number 1, make a sensor, right? Just the housing. I have valves, Ali. That's what I showed. I have valves now. I mean feedback through sensors, yeah. Wait, I could show it again, but I'm way too lazy. Wait. And there we go. I had this. And what I could... Here's your feedback. Here's the feedback that I can do right now, Ali. Wait. Sensors. There we go. Forked light barrier. Forked light barrier goes... Brrr. So I want to evaluate if the cylinder is extended or retracted using this sensor here. Just a little forked light barrier. Limit switches, yeah, I know. But this is the only I mean, I've got different sensors already, but that's the one I can show the easiest. So I've got the sensor. That one I can also connect to the PLC. So let's see. This one has still the 8 bar. That's okay. This one here needs the DCV needs to be active. 24 volts. Oh, the shutoff valve is still closed. Whoops. Shutoff valve activate. So that one is active. It's pumping out 8 bar into this. This one has as output 0 right now. Oh, it's not connected anymore because I deleted it. Doink. There we go. Wait, that didn't hit. What? The sensor should be active. Oh, the sensor is not active because it does not have a supply voltage. So, and now I can basically, through extending and retracting the cylinder using the DCV like you do it in reality, and we can actually see the feedback on the sensor. Let's see. Purpose when I finish my university would educational purpose simulation in VR. I go for it. I'm doing this just as a hobby. That's why I can't guarantee anything, but I'm doing this just as a hobby right now. I can now see boink, 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 boink. Hey, Rasmus. Hi. And I can use this as a PLC input. There's a lot I would need to connect now, but I don't want to. That's not the task at hand. Task at hand is I need to make the sensor. I will need to make... From the sensor, I need to make a ray. Right? I need to make a ray. Task number 2. I need to make like an impact point. I want an impact point, number 3. And all of that should be connected to the electrical side and have a electrical behavior. Supply voltage, so plus, negative, and signal. Can I explain a little bit more about the C code? And hey, hi Rasmus, thanks for following. And connecting to the, I will Taylor. I will explain how to connect it in a future stream because I've done it in another program, but I haven't implemented it here yet. It will be one stream that I'll do it. Because VR is kind of new stuff. Yeah, but VR for education, it's nice. I've been working on a similar project like this, basically as a customer, where they implemented it in VR, but it completely failed. No one's using it. It's nice and all, but of course in the future it's getting more and more. By the way, that's part 4 back here. So I've got a couple of tasks at hand. I'll start very simple, very easy. Very simple, very easy. I'm gonna get rid of everything that I just put in randomly here. And I'm gonna close everything that I've got here on the side. Now, very simple, in my project, I wanna add sensors. I want to add a new sensor folder for distance analog, which is like a laser, right? Using light or ultrasonic, or it doesn't actually matter. No, I'm just gonna have like 3 wire. Hey Darshan, I'm good. Thanks for asking. No, I'm good. It's a good question, Ali. I will have sensors with like 2 wires. I will have with 3. I don't think I will have 4 because I don't really want to simulate the electrical behavior. And the only difference between 3 and 4 is pretty much the electrical behavior. So I haven't planned, but it makes a lot of sense to put there. I'm passionate about it. I don't know if I'm passionate about it. I'm just doing it. Hey Manuel, you don't like tutorials made from Indians that just read from paper. I mean, that's 50% of tutorials on YouTube. No sound? No sound yet, Gordon. Hi. There's no sound yet. With shunt, I don't have shunt resistor. I'm not looking too much into the electrical side. I don't even have current in my program. I just work with voltages currently. I'm gonna make a 3D model, just a very, very quick and easy 3D model. I'm not gonna get into the detail right now. Maybe if I've got some time. So our sensor is gonna look like, whoops. Well, how long is it gonna be? 10 centimeters? Yeah, 10 centimeters. Wink. Let's make it a long boy. Whoops. Just very quick. I'm gonna be done with the model in a second. Sorry, I don't really like modeling too much. I mean, I've started to like modeling. There we go. What is good education purpose engine to make? Oh, I don't know. I'm just doing as a hobby. But I like Unity for making anything. It's easy, it's simple. Its performance is nice. Sensors, inductive, distance analog, component, distance analog. Unity is good for a lot of easy things. People say it looks like shit. It does not, actually. If you do it correct, it looks really nice. Shade smooth. No, whoops. Shade smooth, so it's really nice and round. Let's mirror that bad boy. Mirror around the z-axis. There we go. I will also add a little sphere here in the end. This is where the laser gets out. If you've ever seen such sensors, there's always this element here in the end that's just like pumping out the laser. There we go. So that's our bad boy sensor for now. It's not pretty. It's nothing. Logic gates using VR. Yeah, you can do that with Unity. It should be pretty simple. So I've now got this bad boy. I can use it. There it is. It looks ugly because it doesn't have a material, but I don't. Let's very quick. I got it. It just takes a second. Maybe it takes like a minute. Let's actually add. Let's make it a bit prettier. Sensor. Yeah. Distance analog sensor. By the way, I listen to music, so if I do this or something like that, I just listen to music. No, not new. Add the material. There we go. Now it's just black, but I want, like, this should not be black, so I'm gonna do UV. Wait. I'm just making a picture. It's untitled. I'm an idiot. This looks nice. This is the UV. Like, this is the map. You can't see it, but this is like how it is placed inside the picture. I'll just put it there. Give me a second here. I'm gonna be with the chat again in a second. I'm just wanna make this right. Kind of. It's not completely correct, but kind of wanna. There we go. Photoelectric. Yeah, it's photoelectric. Revolution. Yeah, make a revolution in education. I don't try it. I just do whatever I want. Is this going to be an analog device? Yes, Sergio, it is. Okay. See you later, Patrick. See ya. I stream all the time. How's this little thing called on the front where the laser comes out? Laser out. I call it laser out. There we go. Perfect. Now I just need to paint it. I could directly paint it here now. In theory, yeah, I can, but why doesn't it? Oops. Because I've got the wrong thing selected. Laser out. There we go. Why does it? It doesn't matter. It's okay. No. Just the laser. Yeah. There we go. I just need to draw this region here, and then it's like this laser sensor in the front. It's not pretty for now. It doesn't matter. I just want to see it a little bit. And now we should not be able to see it because I didn't save. Always, if you make changes, always make sure you save. Distance analog, distance comp, yeah. There we go. Hello. Don't you want to look different now? Don't you? You don't want to look different? No, you don't want to. Did I miss out? What did I miss? Would I share the source code for a basic example? I will stream it. And then you can just take that. But there's source code on the internet. You can just take that. UV editing. Huh? It's there. This is there. This is there. This is perfect. This fits. This fits. It's distance analog. This is there. I mean, if I can't make it pretty right now, it doesn't matter. Hey, am I stupid? Hey, Colin. Hey, Alexandra. Hello, 3T Studio. Hi. Huh? I saved. If it's not there now, I don't even care. Okay, I didn't save. The difference was I didn't save. Oh, I'm an idiot. Okay. So now I've got the sensor. Part 1 done. Check. I've got this little thing here in the front. So number 2 is gonna be the tough one. I will not start with it. I will do number 3 first. Which is very, very simple. I basically just want like a sphere that shows me where I hit. It's not gonna be pretty. That's what it is. This is it already. Hit point. I don't know how to call it. It's a hit point now. Let's make that pretty. It's gonna be like light. This is green. No, it's red. Those things are always red, right? I think so. I'm pretty sure. There we go. Pretty. Got it. You had a question, but it was too long for YouTube, Rasmus. Oh no. Oh, that's unfortunate. I might not have read it then anyway. So this thing, depending on where this one hits, I want to see this on the wall here, right? And then I know which point I'm actually looking at. 3T Studio, you cannot use the software yet because it doesn't exist. The software, it doesn't exist. Thank you so much. You're very welcome, Darshak. That helped to crack central government job interviews. Hey, congratulations. That's really cool. Hey, Warlock Games, hi. So, okay. What we will need is now the complex part. This number 2, which is called a Raycast. I know, Raycasting. That's the big thing that every graphics card nowadays can do. My graphics card can also do it, that I got a month ago. Yay. It's been a thing that's been out there forever. Now it's in the hardware. Raycasting means I want to start at this point. So what this Raycast needs is 2 things. The start point. And it also needs this thing here, which is a vector, which is the direction. So I'll need these 2, and then I can evaluate. So I need some code that does exactly that. Easy. Easy peasy lemon squeezy. So let's grab this analog sensor. Let's make this actually a new prefab. Let's go in there. So this one here will need a script. Where is it? Am I stupid? Yeah. We're going to need a script. I'm going to call it distance sensor analog. So this script will have the whole behavior. Basically, everything that I'm going to do from now is going to be in that script. Coding. Hey, we all love coding. Don't need all that shit. By the way, I don't exactly know how this is going to work. I don't know. I'm going to try. I don't know exactly. Save and load options. Yeah, Warlock Games. They are really tough. Yeah. Any ideas how? Warlock Games, I usually, if I save, then it's using the player prefabs. Player prefs. That's how I use save systems usually. But there's also stuff you could download, like pre-configured code. But in the player preferences, you can usually put I'm not in the code right now, that's why. But in the player preferences, just look up player preferences. It's a simple save system. I've got a video about it. Can just look it up on my channel. But it's very basic. It's gonna be really tough if you have more. Okay, so this one is gonna need a transform. Sup IQ Sip. Sup, how are you? Public transform, which is gonna serve as the start point. So this point here, right? Exactly this start point is gonna be the start point. That's where we're gonna This is where we're going to start the beam, right? The raycast. So this start point is going to be a transform. And it is, of course, exactly this here. Exactly the center of our distance, of our little thing here. That's gonna go there. So I can just grab it and put it there because it is a transform already. It's got the parameters. It knows where it is. Next thing that I need is the direction. And I always mess those up, damn it. I will need this direction, just the blue little arrow here. That's gonna be the direction. Pretty simple. I don't need to put that in here. That needs to go in the code. So I will need a raycast. Somehow I'll need a raycast. I have no idea how that works. That's why I'm gonna Google it. Raycast Unity. Physics raycast. There we go. That's exactly what I want. Physics raycast, public static bool, physics raycast, blah, 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 blah. I'll put that on the side. I will try to read it and understand it and explain it at the same time. I know exactly what I do. Physics, because it has to do with physics.raycast. And here's what it needs. It needs an origin. It needs this origin, which is the start point. Do I have to write transform? I think so. No, it's a transform already. Hi Marlu, hi, big fan of mine. Thank you. I'll need the direction, which is... So the direction itself is just this blue arrow. This blue arrow is vector 3 dot, and I always forget what it is. I think it should be forward. I think it is forward. I'm not 100% sure. I mean, from this on, yeah, it makes sense. It is. Let's assume it is. And now I just need a maximum distance. And the maximum distance I want for every sensor to be adjustable. Public float max distance. And the standard maximum distance is 1 meter. Let's grab that. Let's put that in here. And let's hope that we're not going to have an error. We're going to have an error. Why is that? It's not a transform. Dot position. There we go. We're also making a tower defense game and made an enemy waypath script. Yeah, scripting gets very important. I don't know when I started coding. It's probably like 15 years ago. Coding takes some time to actually get into. So this now casts a ray. The thing is... what I still need is probably the hit, right? Out hit. No, here. Okay, I'm just looking at the standard code here. I definitely know what I'm doing. I think this just needs to go here. That might be it. Name hit does not exist in the current. Do I have to define it? Raycast hit, I guess. Hit. Oh, I just needed to define it. I'm an idiot. Which coding language did I start with? The first one I got was Turbo Pascal. Turbo Pascal. It doesn't even exist anymore, I think. IQ Sep, you're exactly correct. I started freestyling a bit. So, if... and I think this already evaluates the hit. There we go. Oh, the semicolon. Let's debug this already. Debug log hit. So now we should already get like just an output hit if our sensor hits something. I guess that might work. Or we're gonna have an error, I don't know. So right now it's not hitting anything. Let's see. If I get closer to the wall, it should hit it. There we go. It hits the wall. Coding with Pascal. Yeah, your dad probably, yeah, when he was younger, but designing blueprints was more interesting. Yeah. Now, Pascal is also a shitty language. It's just very old. So we've got a raycast that actually hits the target. Perfect. Now I want to know what can I do with this hit, actually. What's this hit? It's a raycast hit. What do I have in the raycast hit? I've got a collider, I've got a point. That is amazing. It's probably the point. The impact point in the world space where, yes, perfect. I want this. I don't know what I just pressed. Whoops. There. I want point. That would be amazing. So this one, what I want to do now in the script is put the little circle that I have, the little sphere, at the point where I hit. So I need to import the sphere. Public game object hit sphere, it doesn't matter. So I got this hit sphere. And now I want to put the dot wherever I hit, right? And then I'll do hit sphere dot transform dot position to hit dot point. I guess. Yeah. Good. Shall we try it? What are my working hours? I'm working hours. I'm employed. Where's this hit point? The hit point. I want to put the hit point, of course, in the script here now. Let's see. Okay, so as soon as I hit the wall, right now nothing happens, but as soon as I hit the wall, not exactly what I had in mind. Oh, I get it. I understand. The problem right now is really stupid. Is that the ray goes out, the dot changes position, and when the dot changes position, it has an own collider. So the laser itself hits the dot. I hope that is the case. So that's why it moves back and forth. Let's see. A new sensor invented. Yeah, look at this. Now I've got like wherever it hits. Right. There we go. That's nice. But now it's not going to change the position because it's not there. If it doesn't hit, if it's not there, then else I want to not display it anymore. So I'll go game object, no, hit sphere. Whoops. I will just not show the hit thing anymore. Hit sphere dot mesh renderer? Get component. Mesh renderer dot active enabled false. What? Oh, okay. Yeah. I was too fast. It was like, no, can't do that. Enable this. True. So we can now see the hit spot, I guess. So now it's not hitting. Now it is. No, it's not. It works. Ooh, neat. That's pretty cool. And also I can change the maximum distance here. So that's now a further distance. So like 2. There we go. Even if I rotate it now, it doesn't work. I know the problem. The problem right now is that it shoots out vector 3 forward, but I need vector 3 forward local. How do I do that? Finish this part. No. There's always errors. Vector 3 forward in not workspace, in local. Local forward. Local forward, transferred world, local. God, why? Just use vector 3 constant for local space direction. Cancels. What? That's what I've been doing. God, why would this? Why is this so complicated? Is this your software? Yeah, pretty much, yeah. Huh? Is that what you're looking for? It's got 11 upvotes, so I guess. Copy paste. There is no error? That's good. Let's see. Where's my sensor? There's my sensor. It's still there. Works. Perfect. Oh, I don't have play. Should have pressed play. It's similar to mechatronics from an X. No, it's completely different. No. The MCT, Mechatronics Concept Designer, not really. A little bit, but not really. Okay. Let me delete this first before I do it again. I never really liked the MCD, but the idea is very similar. But this is way more for education. It's got, in the end, it should have a lot more features than that. So I've got the hit and now rotation. That kind of doesn't work still. No, it doesn't. Also doesn't work if I rotate this way. Huh. Still the same thing. Let's read this. Let's continue reading this. Blah, blah, blah. Just for reference. Probably not as you... wait, let me fix my microphone for a second. Yeah, to use a quaternion, but I don't want to. What am I making, Akil? Right now, an analog sensor to measure a distance in an analog way and not just digital on-off, not just Boolean on-off. Local direction is transform rotation times some world space direction. Local transform inverse direction somewhere. Inverse transform direction. What? Hey, Charlie. What's up, big fish? What's up? Let's try this. And yes, I definitely don't know what I'm doing. No error? No error, that's good. If this doesn't work, I don't care about it right now. I'll go into another feature. So far, so good. No, still the same thing. Or am I just stupid? Laser out. No, I'm not. Okay. It just doesn't work. I mean, can I do this? And yes, I know. I said I'm going to do something else, but no, I want to find it out. Can I just take a rotation? Can I take the transform here and then say rotation? And then times vector 3 dot what did I forward? Right, forward. Something like this. I mean, it's a quaternion multiplied with a vector, but it should still work, right? You all understand what I'm doing, right? I don't. Can someone please explain to me what I've tried to do? Wait, it didn't work at all. Something there. Something there. Oh, look at this. And it kind of works with all that, but it works better. It is definitely doing something now. Oh, local rotation. Yeah, I know. I'm really talented. Tron, if you've watched the last 10 minutes, no, I'm not. Let's see. It definitely works. This is completely gone now. It's completely gone. Yeah, okay, I'll keep it with forward for now. I'll keep it in mind. There has to be like an easy solution for this. I cannot believe that they never did like an easy solution. Game object, z-axis. For moving the game object on the z-axis while ignoring rotation. Transform.forward. Is that it? It's close, Kamal. Let's see. Transform.forward. Can I just write transform.forward? Are you? No. No. Doesn't exist. I mean, I would need a transform, but I've got my transform. I can just write forward. No, it needs to be vector. Yeah, I'm close, but I don't really have the solution immediately, so I'm not gonna concentrate on it. I don't want to waste time. I recommend you to do simulation with PLC and Unity 2. Looking to do a conveyor. No, if you just want to do a simple simulation, like do a 2D simulation, there's a tool called Simit. Try to do it with a tool called Simit. Siemens. Try Siemens Simit. For simple things, I like to use that. Okay, let's do the next thing. Let's see what this hit actually has. Does it have a distance? It has a distance. I could just grab the distance from it. Let's see. Let's see if I can just grab the distance. Is that it? Are you kidding me? No, not the Turkish Simit. No, Mohammed. Right. That's why I wrote Siemens Simit. Whenever I Google it Simit, I get those little, the food. But I usually don't want to. Hey, look at this. The closer I get, it shows me like the distance down here. Huh. Let's make that a parameter. Public float distance. It should be protected, but I don't care. I don't want these anymore. Yeah. That's why I wrote it. I thought with your name. Yeah. Try Siemens Simit. Yeah, it's quite nice. Like Siemens Simit is quite nice, and I think there's a free demo where you can use like 20 in and output byte. You look at the distance, like top right. Here you see the current distance to the target. And I actually get the distance. I don't know what it is, but I get the distance. But one problem right now is that I get the distance from... I mean, that's fine. Yeah. That's nice. That's nice. That's nice. I don't want the debug anymore. The debug is annoying. If we don't hit something, then distance should be... let's say -1. And -1 means it's an error. Whoa. Let's see. There it is. Boink. I hit the target and it gives me the distance. Let's say maximum distance is 2 meters. And as soon as I get out of the range with 2 meters, my distance says -1, which means nothing detected. That works. I'm a little bit surprised. But also, that is not correct. I don't want the distance to be -1. I want the distance to be max distance. Because that's what the sensors also do. They give you out the either minimum or maximum voltage, depending on if they get higher voltage the closer you are, or if they get lower voltage. But it basically detects you're at maximum distance. So what I need to do now is transform that into a voltage. The distance is limited. With the maximum distance, this is the limited distance. It's the maximum distance that I can go. And now it's just 1 meter. You see the red dot disappears as soon as I go more far away than 1 meter. And then the distance says it's 1 meter. I can change that to 1.4 or something. And now it's a little bit further. Also 0.3. No, it's just really close. Works. But what I want is also, I want to clamp it. Clamping is a mathematical thing. Mathematical function clamp, I think. Yeah. Clamping, I want the output voltage can only go from 0 to 20 to 10. That's the sensor that I create right now, 10 voltage. So 0 to 10. And the output voltage must be between those. Right? Done. Which I could basically do there, but I will do it with the distance. So the distance output right now is also clamped between 0 and maximum. Which actually already is. Yeah, it already is. It cannot be anything different. I don't need to... It's automatically clamped because the ray has a distance. Nice. What else does Raycasting give me? Anything nice? Texture? What? Nice. Triangle instant. What? Light map code. No. All nice things that I can do, but no. Don't need it. Now what I need is transform this to a voltage. So part 2 here is kind of done. Because the rotation still doesn't work. I'll look into the rotation if the rest works in a minute. It's kind of done. What's missing is part 4, which is the electrical side. And therefore, my sensor itself, this is going to be the easiest because I've got it prepared. My sensor itself needs, as in the image, right? This has 3 electrical connections, positive, negative signal. And I'll do exactly that. Electrical connection, whoops, contact, I think I've called it. Positive, negative, and signal. I just need to add those to the... Like a scale and tier, yeah, exactly. I'll just need to add like them here. I don't have them as like wires right now. I could, but I don't want to right now. I will add that later on. There's a lot still that I need to do, but I'll do positive, negative, and also the signal. All 3 will get something called electrical contact. Done. And of course, our distance sensor script needs to be linked to those. And a signal. And the hit point is a game object, this one here. Got it. So here, hit point, get good, bro. There we go. I can actually delete this one here. So let's see. Oh, boink. It doesn't show up. Oh. What I need to do is with the hit sphere, because it doesn't exist, I need to initialize it once. I need to create it. It's instantiate hit sphere at transform dot location, I guess, dot position. No, just instantiate it. Can I do that? I need to do this. I'm sorry, I don't instantiate a lot. How does instantiation work? This? Requires one type of argument. I got this. How about this? Yeah. Am I stupid? I don't know how simple instantiation works. Instantiate unit. I've googled it already. Object.instantiate. Instantiate object. There we go. That's what I've been doing. Wait. What? Oh, I'm wrong syntax. I'm just stupid. That's it. Okay, so that's gonna work, I hope. The hit point should also not have the collider. Do you have the collider still? No. Hey man, hi. What? Am I just stupid? I don't instantiate very often, so I'm just probably doing it wrong. See, programming is the science of trial and error. There we go. That works better. Oh, this is nice. Look at this. I can actually measure the distance to the to this little thing in the wall. Is that too close? Yeah. I can see the distance. I can actually measure distances now, which is fun. Hey Hasso, hey man, hi. Yeah, I can actually do that. This is pretty amazing. Okay, so what I need to do now is that the output, the signal, needs to be between 0 and 10 volts, which is now very simple actually. Oh, there's probably a math function for it. Let me check if there's a math function for it. Clamp, seal, asyn, approximate, cos, delta equals inverse lerp. It's gotta be lerp, right? Linear interpolates between a and b by t. Yeah. Let's see. I just want to see if that works. Rotation, and the rotation needs to be fixed. Yeah, I'll look into that. Linear interpolation between, what is it? Linear interpolates a and b by t. Okay, a is 0. B is our maximum distance. And t is our current distance, which is distance. Oh, this is missing. Let's see if I hit it. Now I should get like a value between 0 and 1, I guess. Do I? If not, I will just do it mathematically. I'll do it myself. We should get a 1 when we hit the wall. Yeah, almost a 1 and a 0 when we're in the wall. Yeah. Linear interpolation. Hey, that's nice. Mathematics. Who would have thought that you need it? I did not think so in school. Okay, that works. Now the thing that I need to do is the signal. That the signal voltage is exactly that. Dot voltage is exactly the value we just had. Done. Almost. Almost. Let's see. So this one has like the signal output, which I cannot view if I like change the position of this, but I will. So now the distance output should be something around, the signal output should be something around 0.5, I guess. Yeah. Let's see. Now it should still be kind of 0.5. It's 3.5. Oh, it's the distance. Oh, whoops. What? Signal voltage is method. 0 max distance and distance. This. Oh god, mathematics. Oops. Can I make a video on using openness? I have not used openness, sorry. So if I go to approximately 3.5, the signal should be 10 volts, but it's not. It's 3.55 all the time. Why is it 3.55 all the time? Did I write the wrong thing? Signal.voltage is the linear interpolation from 0 to maximum distance with the current distance. Yeah, that is correct. Can someone do math? From 0 to maximum distance, and then we've got distance. Had worked before, didn't it? The debug worked. Did I just do an oopsie somewhere? Yeah, exactly. That is exactly what it is. Like what it comes down to. A11. I won't read the rest of the name, but that's exactly what we need. Like we just need a slope, basically. Wait, I broke it. No, I didn't. That works. God, I'll do it myself. Why? It doesn't do the right thing at all. Oh, fuck off. I'll do it myself. Sorry. So what I have is the following. Oh god, math. I'll need to take a sip of water. Yeah, no, it's very simple actually. So signal not voltage. So my output voltage will be the current distance divided by the maximum distance multiplied by 10. That should be. Oh, maybe it was because it's not a. Oh, maybe because. I don't know. That should be it. Did I do this? Be careful, Siemens might steal it. No, they won't. I work together with Siemens and they don't care about anything that I do. I would sell it to them, but they are really not interested. So I've got the distance, I've got the maximum distance, and now my output signal voltage should be dependent. So now if I go to almost 0, it should almost be 0. Yeah, 0.8, that's fine. If I go far away to 2-ish, or to 2, it should be 10. Whoa, there's a rounding error in there. No, sell it to us. I will, like, sell it to students and stuff. Very cheap, actually. But yeah. First, let me finish it. Hey, Gurov, hi. Is that a rounding error? Are you kidding me? That is quite big. No, it's not. It's because this is still in here. It needs to be outside. the last time I'm moving it and the last time does not get calculated because I'm outside, which actually is better. Signal is now this. Oops. Let's see if I get like this. Now it should be exactly 10, yeah. Yeah. I mean, it is not much calculation, so I can keep it outside. Yeah, I'll do that. So, okay. But this here should only happen. I only want an output voltage if my input voltage, if my supply voltage is big enough. So if positive voltage minus negative voltage is greater than, let's say, 20 volts. And the sensor is not broken, which I don't have because this is missing electrical component. There we go. Only if that happens, we will have the voltage output. If that's not the case, my output voltage will be 0. There we go. So that might work. So I've got my sensor right now. I can get closer. It will even detect it, but my output signal should be 0, which it is. It's not dependent right now on the sensor because we don't have supply voltage. The sensor does not have supply voltage. I need to add supply voltage, 24 volts, and now I will have an output signal. Let's see, now it should be 10. Now it should be something. Praise the sensor, praise the sensor. Now it should be something around 3-ish. Yeah, that's fine. That works. Also, if the sensor is broken, it's got an attribute now that's called broken. If it's broken, there should be no output. Got it. Works. So the sensor works fine. Except one thing. That's the thing that I have dreaded. That I will actually not... I don't know if I will be able to solve it very quick. Hey, Cardi, hi. Because it's the direction here. This should work. Sorry for biting my fingernail right now, but that's what happens when I think. So what I need is the direction of this thing. Just this. I just need this here. In the local this. I just need this. Which is this, but this. Huh. Does anyone have an idea how this works? Can anyone Google it? I'm thinking right now. I'm thinking, and I know what I'll do. I know what I'll do. I will Google it. Hi. Local rotation direction unity. Maybe transfer local look rotation. Direction to look at. Parent up. A draw helper, no. Wait, there was another thing that I wanted to test. Give me a second. I definitely wanted to test that. Where did I have it? Earlier. It was earlier. I looked at it and I was like, whoa, this is amazing. Damn it. It was on Google somewhere. Raycast Unity. I think it was here, and I could see it. Transform? No. I could see it somehow. You can see the ray somehow. What is the software? It doesn't have a name yet. Is it in the Raycast? Nah, it's okay. Damn it, I want it. Because then I could see the ray. That's all. It only works for the debug anyway. It's okay. I don't need it. I need it. I want it. Debug show Raycast Unity. Debug draw ray. That's exactly what I wanted. Debug draw ray. Draws a 10 meter long ray. Debug.draw ray. Let's see. Debug.draw ray. And then we pretty much need this here. Max distance. And color.red. Let's make it red. Why is max distance not allowed? Can't convert from float to color. Do you not have maximum? Oh, it doesn't have. Oh, I found something else in that moment. Forward times max distance. There we go. Does that work? Will it show me the ray now? That would be amazing. I mean, it should. Does it? There it is. It's not. Oh, I would have to... it only shows it when I'm in distance, right? No. It doesn't show it at all? That doesn't make sense. Debug to draw. Start position, vector 3 forward times maximum distance. Yeah. Hi, Luis. Hi. Let's keep that maximum distance. Maybe that messes it up. Oh, do I have gizmos off? I have got gizmos off. Shows it as a gizmo, I think. Look at it. Oh, it's so cute. Look at the ray. Oh, this is pretty cool. Pretty cool. Does it show that if I export it? That would be cool. But now I multiply it with the distance here. I had gizmos off, which means I don't show those things. There it is. Oh, look at how cute it is. And if I make the maximum distance higher, look, I can actually change the distance. It's barely seeable for you, but it's amazing. Does it go through the wall? Or does it actually get shorter now? No, it doesn't get shorter because I got the thing, I think. But look at this. We can actually see the point where it hits. Hi, Artux. Hi. That's pretty cool. You can see the hit point. Okay, this is amazing, actually. Boink, boink, boink. But now this is the problem here. You see it? This is the problem that we had the whole time. That if I rotate, it doesn't rotate the ray. This is actually pretty cool that I can see the ray. I will not do it right now, but I'll keep it in mind. So, how do I now get the local frickin' forward? Unity local forward. God damn it, there's gotta be an easy solution. What? No. I mean, everyone does that inverse transform thingy. Is there any way to easily get the local direction? A bit like transform forward. However, I imagine child blah 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 blah. What have I been up to? I'll just program him a little bit. we're making an analog sensor right now. We're making an analog distance sensor. I'm pretty much done. The only problem that there is with this analog distance sensor is that if I rotate it, it does not rotate the ray that's getting out there. Like right now, it's not really doing that. It should now shoot almost up, but it doesn't. It shoots left. Which, yeah, that's what I've programmed in, but that's what I want to change. And I need to search for it because I'm not a good programmer. What you're looking for is the child's forward effect. Yes. Yes, in its parent space. Yes, rather than getting into the word. So we would do this in a script attached to the child. Inverse transform direction. I mean, that's exactly what I want. So if the child is pointing in the same direction as the parent, you'll get 0, 0, 1. If you rotate the parent, that number won't change. If you rotate the child... No, that's exactly what I want. This is equivalent to child transform local rotation times 4. That's what I did earlier. That's not really working out, I guess. Because we're not rotating the child, we're rotating the parent. Can I just still do that? Can I just use this? Did I use this inverse transform direction already? No, that's wrong. Wait. And yeah, I gotta play around a little bit. I'll find it at some point. I'll just copy the whole thing. No, can I just do transform.forward? Is that the thing? Is that, can I do this? Is this legal? Can add the angle. Yeah, I can add RPG, exactly. That's, I don't want to do it because it's more complex. That's what I meant is with I have to work with quaternions, which are angle thingies. And I didn't fully understand them, so I don't want to learn about them in a live stream. Look at this! That's what I wanted to search for as an easy solution. Look at this, it's beautiful. Yes. Yes. I want this easy solution. So this, god damn it, that makes it. Why? Yeah, that makes sense. But didn't I try this earlier? Yeah, look at this. Transform the forward. Hey, Hotdeck 666. I even did this earlier. I have the exact code there. I have the exact code here. Why did it not work earlier? I had it. What? I had the exact code. Huh. Very, very strange. So let's do this. Boink. Boink. I want to draw the thing actually. Guten Morgen or gute Nacht. Hi, Orang Saib. It's more like good evening. I want to have a parameter that actually shows it. Public bool show array. Starts as false. Definitely, I want that. If show array is true, then I want to show the frickin' array. Where is the button that I'm searching for there? Hey Majid, hi. And hello everyone that's new to the club. Not times max distance, now I really want times distance. That should work. I guess. We'll see. So now I've got this. If I show the array, there it is. What a beaut. I can change the maximum distance. You can barely see it. If you're not watching in full screen, you can't see it at all. And now it should actually cut off if I get closer to the wall. Oh, look at this. Oh god, this is beautiful. I love it. I love this. So that works. And we now also have the output voltage. It's done. Like it works. It fully works. Can I explain how I connect the cut with the V? Sergio, this is just Unity. Just download Unity. I've got a video series on it, which I kind of abandoned. I'm sorry. But yeah, moin servus. Hi, Faith Lux. Hi. Looks amazing. Thank you, Sergio. Yeah, it is. It is actually, it works. I'm surprised. How long is it? 1 hour, 26 minutes. I was to my fiance before I started to stream. I was like, hey, I'm gonna stream a little bit. And I was also like, it's probably gonna take like 1.5 hours till I have accomplished what I want to do. And it's 1 hour, 26 minutes. And I'm in time. I've got 4 minutes left. Oh, this is amazing. I love this. Now I could hook this up to the PLC and stuff. I won't right now. But I could. Shoulder right, burp. Love it. Look at this. I can rotate it. Yeah, no, why? Oh, the ray itself. The ray does not rotate. Oops. Oops. The ray is not vector 3. The ray it's simple. Transform. Dot forward. Yeah, why did that not work earlier? So surprised. Oh, this is cool. I love it. I love when things work. I didn't think it would work, but it works. Absolutely love it. Yeah, there we go. This is not completely PLC Shio Yogi, but it is definitely related. Oh, this is amazing. I love this so much. There's a PLC in here. There. Is it? There it is. Okay, just to play around. I should make a video about it, but just to play around right now, I'll do something. I will do a small 2-step system. Let's see. Oh god. Okay. I shouldn't. It's probably gonna take like half an hour to make because my software is not optimized. I'm not gonna use coding right now. Here's the thing. Okay. What I want to do is the following. I want to make this correct. Like it's in reality. I want to have like a power supply. And I want... I shouldn't have started... Why did I start with the power supply? What I want is a cylinder. This cylinder can extend... should automatically... It should extend. This cylinder should extend. And as soon as it's extended, I want a second cylinder to extend. Right? That's it. Sounds simple. But what I need here is this one has to be driven by a DCV. The DCV is connected by is controlled by a push button. So I want a push button. Right? A push button. All of this is powered by, of course, a power supply. Right? Then I definitely have the sensor here. I'm not going to take the sensor we just made. It's analog. I just want a digital sensor. So here in the end, there is a position sensor, a light barrier. This light barrier detects the thing. So I press the button. The DCV activates the button activates the DCV. The DCV is going to activate the cylinder. Of course, I also need a source, a pressure source. PS, a pressure source. That feeds the DCV. I press the button, the DCV pushes the pressure from the pressure source to the cylinder. Cylinder extends. The light barrier detects the extension. Then I want a second DCV that is connected to the light barrier. So light barrier gets connected to the second DCV. The second DCV is going to push this cylinder out, which of course we also have the pressure supply connects to the DCV. And that's pretty much it. So this one here, this power supply needs to power the push button, of course, and also the sensor. That's exactly how you would set it up in reality. Does anyone understand what I want to do? Hey, Juan. Hey, Amin. Hi. Or Amine. Hi, the master's back. Not really. I'm just having a bit of fun here. So, okay, that's the plan. God, it's not gonna work. I'll need to put that on the side here. I'll need the plan. I hope you made a screenshot. If you need the plan, make a screenshot right now. I'll give you 5 seconds. I'll pour myself a water to understand it. Okay, you got your screenshot? I got mine. You will see what I want. This is now actually really simulating a very, very simple mechatronic system. Oh god, the most problematic part will be finding all the components that I need. I hope. So I will need like a power supply to my system. I've got a power supply. I'll just put it there. I'll need a power supply. Let's crank that bad boy up. It's going to be bigger. So I've got my power supply, 24 volts. Output voltage 24. L in. I'll need to simulate the input voltage because, oh no, what I need of course is as well a power source. So 100% correct as it should be in reality. I have a main power plug, there it is. This is the power source. This comes from the wall. Let me use the sensor on the cylinder. Half an hour will not be enough. I don't know. I'm just playing around. Right now I actually want to see if my tool works. That's the reason here. It's not pretty. Everything here is not going to be pretty, but I don't really care. Why do I not have those as voltage already? Oh, power supply. No, fuse, breaker, workpiece. No, this should have 230 from the beginning. Let's give those 230. Okay, got it. So, from the power plug to the power supply, that's going to be 24 volts. Then I want the push button. So I want the push button. There's a push button. I turn off gizmos, of course, because that's going to be annoying. So I've got the push button. Okay, got it. Perfect. I should maybe put that all on the wall, actually. Let's delete them. I want to make this clean and nice. So let's put it all against the back wall there. Okay, I want the push button that's there. Is big, is a chunky push button. I want we can have a main switch. There we go. Let's make a main power switch. God, I could really make a lesson now out of this. So I've got the main power switch. Of course, before the switch, I have the power plug. There we go. Then I have the power supply. That makes 24 volts out of the voltage that goes in there. God, if all of this works, I'm going to be so, like, wow. I'm going to be so flashed if anything works. This goes in there. Then I have the push button. I've got the push button. Let's give it a name. Let's give this push button a nice name. This is going to be Go Gadgetto Cylinder. There we go. So if I press the push button, this will activate a DCV. Where is my DCVs? DCVs. I want to have spring DCVs because those are easier. Down here, I'm going to put it down there. So the push button is going to activate the DCV. But the DCV definitely needs like an air supply, which is going to be with the shut off. I don't have one yet, like a what's it called? Pressure generator. Compressor. I don't have a compressor yet. So I press the button. This one here will take the air from here and put it to the cylinder. Whoa, if all of this works, I'm really gonna be so flashed. Okay, so this is gonna activate this cylinder. This cylinder here is gonna be detected by the sensor. I could take the analog sensor, but I'm taking a light barrier. Oh, another light. A forked light barrier. Here I need to... Now I need to take care of the placement of the sensor, of course. So let's place it so that the thing will actually detect it. Oh god, do you know how much wiring I have to make? I'll never delete any of this. I'll just keep it forever. So I'm gonna have that and put that... I don't know where. Here should be fine. Maybe. Okay. Next. If this gets active, if the sensor gets activated, I want a second DCV. This one here. To activate a second cylinder. There we go. Okay. Easy. Got it, everyone? Do you understand? God, this I could really make a lesson out of this. I love this. You don't know how much I love this right now because I've worked on the software, and now I could actually use it, which is crazy. I could actually give it to someone and use it. It's not usable right now. It's not pretty, so I have to change it still a lot. Funyang, it's a software. I don't even know what it is. It's a software. I made it. Okay, let's break it. Yeah, you're right, Hartux. Let's break it. It's gonna break. I will have to make all the connections, right? So I will have to make the wiring. I don't have wiring yet. So this one here, the main switch. The main switch, let's use L1 actually on this. L1 on the main switch is gonna be connected to the power plug L1. There we go. Got it. The power supply here. I should also connect N, but N doesn't do anything. The power supply is going to be driven by the main switch. So the power supply L1 in is going to be driven by T1, which is the output of the switch. So if we turn on the switch, the power supply will turn on. We can already test that. Shall we? We shall. Software name doesn't have one. It's Philip is awesome. That's the name. Love the name. Okay, let's turn on the main switch. Active. Yes. Okay, that works. First part works. Do you see that little LED? If I turn on the switch, the LED turns on. So the power supply works. Cheers. So part 1. Yeah, someone around 10% also joined late. Hey, yeah, it's... Sorry, there's a replay. You can always watch the replay if you want. So, okay, power supply works. Next. The push button. I want the push button to connect from the power supply to the DCV. So, NO13. Yeah, normally open contact number 13 is connected to 24. So far we have 230 volts. This makes 24 volt out of it. 24 volt output from here connects to the push button. Input number 13 here. So L plus out, no. Power supply, yeah, L plus out connects to the button. Okay. Okay, that's okay. What I also want is that I want to drive the... there's an LED in there in the push button. Let's illuminate it. If I press the button, if I press the push button, the LED should come on. The problem right now is I need to run there every time. To press the button. Character, where's the character? Come here. I need to grab my character and put him there. So because I manually have to do that. And this is what one task will be the operator. So I can, this is like really playing the thing now. Turning this on, I see the power supply is on. If I press the push button, you see the LED in the push button turns on. That works. So 24 volt works. I love the name on it. Good. Go get the cylinder. It even says the name. Love it. Okay. Next is the push button should then extend those cylinders. Let's put the cylinders actually, no. Cylinder and, where is it? The fog light barrier, where's the fog light barrier there? And the cylinder, this one. No. Globe it. No. Center. Okay, that kind of, it needs to go somewhere here because I need to see it all. Kind of okay, yeah, kind of okay. But it has helped me so much. Is the software you're working with now free? There's no software yet, Mr. Snippet. But you're welcome. So, okay. So I got the 2 cylinders. I just want to see them here. That's why I put them there. Okay, let's see. I love that a lot of people ask what the software name is. It doesn't have one. I'm developing it right now. So let's turn on the power supply. If I press the button, nothing happens yet. Because if I press the button, this here should activate. So this DCV needs to be connected to the push button. So DCV has an input, of course. The DCV signal, yeah, needs to be connected to the push button, which is NO14. That should work. Okay, the DCV itself also needs the pressure connection. The left input is the pressure connection from this one here, which is the pressure source, which is not a real pressure source, but that's okay right now. Shut-off valve. Shut-off valve, let's say 8 bar input. So the output of this goes on the left input of this. And also for the other DCV, I want to do the same. Left input goes the signal output of this one here. God dang it. Oh, there's so much wiring to be done. Why did I even start this? Left input, left input. Good. Good. So this one here, then the output of this one here needs to be connected to the cylinder. So the cylinder, God, that's so much that I've opened now. The cylinder, it's got to be prettier in the final version, of course. It's just, I don't have a UI yet. The extension port of this will be connected to this output port of the DCV here. Got it. This is done. Then I have my sensor. The next thing that's going to be activated is the sensor. The sensor needs a couple of things. It needs a positive, it needs a power supply, which right now, the positive power supply, I will just manually override and say it's 24 volts. There's no. Oh, I'm an idiot. The power supply is our power supply. We have one. This one here. Whew. L plus out. If this works, guys, I will be so surprised. L plus out of the fog light barrier. Yeah, that should work. Okay, good. Then the signal from this should be connected to this DCV. So this DCV right here should have as the solenoid input, should have the light barrier. Solenoid input is this one here. Where's the light barrier? There. The output of the light barrier is this. Okay, got it. Goes to the signal from this. Got it. The power, I already have the pressure from this. The only thing that's left is for this cylinder. The input for this cylinder should be the output of the DCV. Done. Did I forget anything? Did you listen? Did I build the software to train students? Yeah, pretty much. Yeah. Okay. Play. Play, I guess. Let's let's see. Okay. If I press this button, nothing is going to happen because the cylinders, we don't have power. Okay, if I turn this on, we have power. I press the button, LED is on. The cylinders won't extend yet. Why do the cylinders not extend yet? Because we don't have a pressured power. Now I have air pressure. And if I press the button now, the DCV should activate extending the cylinder. Once the cylinder hits the sensor, this cylinder should extend. Who wants to bet? Who wants to bet? Is it gonna work? Wait, can I actually do like a what's it called? Not a survey, a Umfrage. There we go. Will this work? Yes? No. Let's see. Oh, okay. You should have a pop-up. It should ask you if it's gonna work or not. Does it? Is it there? It will work 100%, you say? I would press... There we go. No. Who says no? Who says no? What? I see you. I see you. You saying, oh god. What? I say no, but I cannot vote. But I would say no. 50-50. There we go. Thank you. Okay. So I press the button. Let's big screen. Okay. Fingers crossed. I forgot the pressure at the second cylinder. Wait. Did I? Maybe I did. So the second cylinder has the extend port. It's connected to the output of this DCV. This DCV has pressure input. There, left input is connected. No, it's connected. But thank you, Juan, for paying attention. So that means you are paying attention. Great, love it. Thank you. Let's see. I turn this on. I turn this on. Let's do it. Yeah. Look at it. Oh god. Oh look at. Oh god. Oh look. Just look at. Oh no, it's okay, Juan. Don't worry. It's fine. Thank you for paying attention. Look at it. Oh, this is so cool. This is so amazing. Who said no? Who said no? Who said no? Oh, I love it. If I turn off the air pressure, for example, it won't. Like, what happens if I keep the button pressed right now? If I press the button while I hold shift, the button stays pressed. What happens if I turn off the air? Oh, they both retract at the same time. That's exactly what would happen. If I now turn off the air, both of them don't have pressure anymore, so they will both retract at the same time. You said yes, thanks, Shiva Yogi. At least someone. Oh, look at this. No explosion, I'm so sorry. Oh, this is so amazing. I'm so shook that it works. I could use this. I literally could use this already in lessons and make like a 5-hour lesson on all of this. Probably not. Yeah, I could build up on it. Let's actually use the analog sensor that I've added. Where is it? God, everything is open right now. Oh, there's so much. Mechatronics components. Analog sensor, where's sensors? Does anyone see? There's 30 sensors, distance analog. Let's use the... Oh, that one is chunky. Why are you so big? Let's angle the sensors so that I can touch this one here. Hey, Nomis, hi. Ali was here. Ali was here like an hour ago. I haven't seen him since. Okay, why is this sensor so big? Why did I make it so big? This is like a crazy big sensor. So, okay. Let's make this 3 meters. So now we will get the distance displayed there. I guess. Will we? Yeah. I haven't angled it correct. So it's not completely correct there. Show the ray, please. Giasmus. Let's actually point it. It's kind of okay. No, it needs to be a little bit higher. There we go. Now I hit it. Okay. Now we get the distance is gonna be displayed there, and also, God, I'm so excited. So now we have like the voltage, the output voltage of the second sensor, which displays the distance actually that this one has traveled is going to be displayed. So let's turn this on, Doink, doink. And you see the voltage actually. I mean, it's very small, but we see now it's 4 volts. Now it's 1.8. I could use that in a PLC program to evaluate how far this has advanced. Why is it not showing? Gizmos there. Near. The ray. Yes. Yes! I can actually use this. I'm gonna make a video about this. I'm gonna do everything that I just did, I'm gonna put in a video. I'm gonna make a nice learning experience out of it already. To advertise my software that doesn't exist yet. But I love it. This is so amazing. And yeah, sorry that I'm so excited, but I just look at it. It works. Now, what I could also add, look at all the components that I already have as well. Like a circuit breaker. I could add a circuit breaker here. Right in between somewhere here, I could add a circuit breaker. I could add a circuit breaker. I could add, that's it, I don't have more. Oh, I should actually have used like a relay, like a contactor here in between somewhere. Don't ask me where, but I should have used one. Oh God, I've got so many. I'm so amazed. We definitely need an emergency stop, right? Why is this angle so strange? It doesn't matter. Could have used I could have used so many things. God, I'm so excited. Okay, I'm too excited. I gotta take a rest. I'm too excited. I gotta take a rest. This works. Crazy. Crazy. If you're not impressed, you don't know what I've been doing. And it's not really impressive if you don't know what's going on, but it's so nice. It's so cool. Now the question is one, yes, I am developing this. Yes. And if you ask for the name, it doesn't have a name. I love it. Oh. Please 2 lines about you are doing, please. You mean how I'm doing? I'm doing great. I'm doing good. Look at my smile. I'm doing great. I still have some work to do actually today, so I still need some energy for later on. This is so great, guys. I hope that I can make like a demo version or something very soon where you can add components, you can link them and stuff. There's still a lot of work to do. I'm crazy. Thank you. Yeah, I know what you mean. Great. This is so amazing. I love this so much. Okay, guys, I will need some energy for later on. Thank you for joining. I will probably even make a small video about this, not even joking. And you just watch the video if you don't know by now. Anyone that does know what's going on, just watch the video. Just be surprised. But for now, I'm going to take some rest. Thank you for joining. I'm trying to make the technical streams more regular. And now we're making really good progress. I love it. Yeah, thank you for joining. Have a nice rest of the day. I'll see you next time around. Stay safe, stay healthy, and bye-bye.